Okay, so this week we're going to look at how to convert from moles to moles. This is going to be talking about two different molecules though. So if we have a certain number of moles of molecule A and a certain number of moles of molecule B, there is going to be a ratio between them. And we find that ratio in our balanced chemical equation. This is what we used to do. We used to go from atoms of one substance to moles of that same substance, and maybe even moles to grams. But we've been talking about the same substance the whole time. So today we're going to learn what is this big part here, going between moles of A to moles of B. And let's look at this first problem. All right, so here is our equation. This is not balanced yet. That's the first thing that you should think to do every single time is my equation balanced? You should check that, and if it's not, then go ahead and balance it. All right, so we have potassium, 1 on each side. That looks good. Chlorine also has 1 on each side, so that looks good, but the oxygens are not balanced. There's 3 on the left side and 2 on the right. I can think, what number can I get those both to? We can put those both to 6. If I multiply that oxygen by 3, I have 6 oxygens on that side. If I multiply this entire molecule here, KClO3, by 2, I now have 6 oxygens there, but then that also gives me 2 potassiums and 2 chlorines, so I need to make sure that I have 2 on the other side for each of those as well. Okay, that is balanced. Now let's look at our questions here. How many moles of oxygen, O2, will be formed from 1.65 moles of KClO3? So we are given this part, moles of this. Okay, so this is the exact same way that we'll start. We're going to use our train tracks. 1.65 moles of KClO3. That's what it gave us. And we're looking for the moles of oxygen. Now oxygen is over here by itself. And you'll notice there is a difference in the number that's in front of each of these. We have a 2 in front of our KClO3, and we have a 3 in front of our O2. So that means that that is the ratio of oxygens to KClO3s. Just like before, we're going to have to make sure that we put the units down here that are going to cancel out the units from up here. So let's go ahead and do that. Our units are moles of KClO3. And that is just right from here. Moles of KClO3. How many moles of KClO3 are there in this equation? Well, that's just the coefficient out front. We have 2. All right. How many moles are we trying to get to? Well, we're trying to get to O2. How many moles does that have in the equation? That has 3. So we put our 3 up here, 3 moles of O2. Okay, we cross off the units that are going to cancel. We pull out the calculator. 1.65 times 3 divided by 2, and that's going to equal 2.475 moles. Moles of oxygen. Okay, that was our first problem that we've ever done. That was converting from moles of one thing to moles of another thing. Let's look at number 2. How many moles of KClO3 are needed to make 3.50 moles of KCl? All right, so we are talking about KClO3 again and KCl. So it may look like we're starting that with our KClO3 here because it says how many moles are needed, but we actually always want to start with the thing that's given to us in number form. So the same way that we started last time, we're going to put 3.50 moles over here, and that is moles of KCl. All right, we want to divide that by the same unit, moles of KCl, and we are trying to get moles of KClO3. Let's look at our equation to see what the ratio is between these two things. Our moles of KCl come from right here, 2. Our moles of KClO3 comes from right here, also a 2. So, I really don't need a calculator for this, but I do want to make sure that I show you this. If we multiply by 2 and then divide by 2, it's not going to change our number. We're going to have 3.5 moles of KCl still. 3.5 moles of KCl and of KClO3. KClO3. Just to show you how I got those units there, I did cross this off in my head. So all that was left was this part. Was there an easier way to do that? Yeah, I honestly there was. We didn't have to do all those calculations because if we looked at our equation, these have the exact same ratio. So whenever there's a certain number of moles of this guy, there's got to be the exact same number of moles of that guy. All right, last question here. How many moles of KCl will be formed from 2.73 moles of KClO3? Let's start with the number that they give us, 2.73 moles of KClO3. All right, we're trying to cancel that unit out, KClO3 out. We're trying to get 2 moles of KCl. Let's look at the ratios one more time from the equation. That would be a 2 here and a 2 here. Once again, we don't need to go through all these calculations because we know that these have the exact same ratio. So if you've gotten to this point and you've realized these have the exact same ratio, then I already know that my moles at the end have to be the exact same. 2.73 moles of KCl. Okay. On the next problem, you're going to see something a little bit more difficult. It's not just going to be going from moles of one thing to the other. We're going to be starting from grams, going to moles, and then over to grams. So a few more steps in that one.